All right, now we're going to do some more complex versions of friction and inclined planes, kind of the friction inclined plane combo. And if you are wondering how do you solve an inclined plane problem, I'm going to reference you back to a previous video on just straight up inclined planes. It might be kind of familiar to this, but it definitely did not have the coefficient of friction. So here we have my buddy Jason Todd, the Red Hood. He's sliding down an incline, or at least I did my best with the picture. It's really difficult to find good pictures these days. But anyways, he's sliding down the inclined plane, and he's going to need to calculate his coefficient of friction. I don't know why, but for some reason this is what's in his head. So we want to know, I know it's weird things to think about, but we want to know what's the coefficient of friction, assuming he is sliding at constant velocity. All right, so he's going at constant velocity. So that's kind of crucial. So to do this, we're going to draw a beautiful force diagram of him. So I'm going to draw it on the incline. So here he is. Now his mass, fun fact, is about 90 kilograms. So he's sliding down here. And then friction is always parallel to the surface. There's going to be a normal force pointing up. And then gravity is going to act, let's see, I'll do some different colors so we can distinguish. The force of gravity always acts straight down, but that would not be in either the x or y planes. So we're going to have to break that up. But we do know the angle over here, so we can use that to do some basic math. And so I'm going to break this up into its x and y components. So I've got FGY, and I've got FGX. Now, since we're traveling at constant velocity, we know all these forces are balanced. Every single one. So all planes are balanced with each other. It's kind of important to note in this one. So then, if I'm going to go do some math, I can say, well, I'm going to do a net force equation for each plane. So let's do, I don't know, let's do the y plane first. I usually like doing the y plane first with friction because usually, not always, that's where I get my normal force from. So now here I've got the normal force minus the force of gravity in the y plane. And then I can expand that force of gravity in the y plane because we know that force of gravity in the y plane is equal to mg. That's force of gravity. And since it's the y plane, it's going to be cosine of the angle. And the angle here is 40 degrees. So that equals that. So now if I punch in all the numbers, force normal minus mg, again his mass is 90, times cosine 40. Always make sure you're in degree mode when you do these. Then I get a normal force over here, 675.65. So that's what my normal force is equal to. 675.65 newtons. It's good to know. So then I can do an equation for the x-plane now. Let's go with red. Yay. No, darker red. Yes, be dark. So then in the x-plane, I'm going to say, yeah, we'll do it over here. I got room. That is not red. You've lied to me so much, Mr. Penn. You're supposed to do that darker red I liked. All right. Sum of the forces in the x is also equal to 0 because we have balanced forces in the x as well. So we've got a positive force of friction because it's to the right, minus the force of gravity in the x equals 0. So now I can just kind of break this down. I'm going to break this down kind of step by step. So force of friction is equal to mu Fn. Here's my normal force that I care about, minus this guy, which is going to be mg sine 40 degrees equals 0. So now if I punch all the numbers in, I don't know what mu is. I know the normal force from over here is 675.65 minus mg sine of 40, which is going to give me 90 times 9.8 times sine of 40. That's going to give me 566.93 equals 0. So now I can just do a little math. So mu is going to then be equal to, let's hope it's less than 1. If I did it right, it's always less than 1. 675.65. Yes, I did it right. It's always exciting when you do stuff right. We'll just round that to 2 digits. I got 0.39, but 0.4 is good. So then we know that that's the coefficient of friction. So again, I did a net force equation in the y-plane. Help me get my normal force, because again, the normal force that I care about is always perpendicular to the force of friction that I'm trying to solve for. So friction was in the x-plane, I needed the normal force from the y-plane. And then I used my y-plane, solve for the normal force. Then I went to my x-plane, substitute everything in, and I solved for the unknown mu value. So I figured out the coefficient of friction acting on him if he was sliding down at a nice constant velocity. So, hope that helped. Inclined planes and friction. Lots of fun. Good times. Hope to see you next time. Bye-bye.